Okay, welcome to Lab 6. The purpose of this lab is we are going to continue learning a journalistic approach to data analysis in R. We're going to continue doing all the things we've done in previous labs, including working in our markdown files, loading, cleaning, making sense of, and analyzing data with the tidyverse framework of packages. We're probably going to create some new columns, summarize data, join together some data, do a little bit of data cleaning. Today, the real purpose of today is to learn how to use the ggplot2 package to do some basic exploratory visualization, which can be a really important part of analysis, helps you ask better questions and identify interesting trends. So, just like previous labs, this lab works by following along with the video, following along with the R markdown file, and as you come across things that say task, I'm going to want you to do something. Typically that means creating or modifying a code block or by writing some custom code. When you're finished, we'll go over this at the end, but you're going to save your R markdown file, knit it as an HTML file, and upload it to Elms. If you need help, these are all the same resources you've seen from previous weeks. A lot of great tidyverse related things. There's something new in here that I just want to call your attention to. This is a cheat sheet for ggplot2, which is the visualization library we're going to be using in R, and that looks like this. Just a lot of nice little tips for using ggplot, which again is part of the tidyverse universe, and it's a package that helps you visualize data. And then there's also the documentation too, which is really useful. Helps you understand what the different functions are, how you might draw different types of charts, and how you might customize them by adding things like a title or a legend. Okay, so the setup is the same. By now you should have come to this part, but you're going to rename the file that I provided, lab06, first name, last name, and you're going to put it inside of your Git repo. Okay, so the first step I want you to do is to load packages. We always do this at the top, so we're loading three packages today, three packages. Tidyverse, which we use for all sorts of great data science goodness, data analysis. Janitor, which we do some data cleaning with. Mostly we use it to rename column names. We're also going to learn, we're going to load the Arcos R package, and this is a package that makes it easy to access the opioid data released by the Washington Post, and I'll go over that again just briefly below. We are going to be making extensive use of a package we haven't used before called ggplot2. We don't need to load it separately because it loads as part of the tidyverse. Also later on, I'm going to have you load some packages below that are designed to help with very specific tasks within ggplot. I'm going to have you load them down there because I don't want to create any extra confusion. Just know that, remember that typically we want to load all the packages we're working with at the top of our document. Okay, so go ahead and run the package below, and remember, load the packages you'll need below in this code block, and remember that you need three. You need to load the tidyverse, you need to load janitor, and you need to load Arcos. If for some reason you're working on a machine where these haven't been installed previously, you'll need to use the install.packages function to do that. So go ahead and run it. And the first step we're going to do here is we're going to load data from the Arcos R package. And so remember, this is the DEA's Arcos database, which documents shipments of medication. In this case, we're working with a slice that was obtained after a lengthy legal battle between the Washington Post and the Charleston Gazette-Mail to get release of this data. We're going to be working with some subsets that are made available through the Washington Post's Arcos API. They made this into a nice R package where we can access data in particular ways. Instead of in previous assignments, we in most cases, we're uploading or downloading data, saving it in a folder, and then reading it into R. We're going to pull in data directly from their API, which is really nice. So remember, to get access to their API, we need to store an API key. It's sort of a password, essentially, that will allow us to interface with the database server where the post has this information. Remember, there's a list you can pull from in the Arcos API package. Any one of these passwords should work. So first we're going to store the key. I've just picked the first one off the list here, and we're storing it as an object called key. Okay. And what I want to do is first I want to pull into R one of the tables that exists behind the Arcos API. So I'm going to create an object called Arcos County Pills per year, and I'm using the summarized county annual function, and I'm feeding it my key. And then the last thing I'm doing is just making all the names of the tables, the columns, standardized here. So when we run that, it pulls in a new data frame called Arcos County Pills per year. It's got 21,000 observations of 6 variables. Typically this is, there's one record with a total number of pills, that's the dosage unit, and the number of shipments for each county for each year. So Abbeville, South Carolina, we've got one for 2006, one for 7, one for 8, 9, 10, 11, and 12. Okay, so we've got our data in that we're going to be working with, and I just want to talk for a second about why we might do these exploratory data visualizations as part of our analysis process. This is separate from, but related to, you know, the kind of final visualizations that we might publish along with stories, or serving essentially as a story to our audience. What I'm talking about here today really is making use of data visualization as part of the analysis project. When we are asking questions of data sets, it can be really useful to see the answers, or to think about producing the answers as data visualizations that we can display inside of our Markdown document. Why might we do this? There's a bunch of different reasons. They include, it can really just help us see trends that we might miss just by looking at tables. There's something about visualizing data that can make it easier to understand. This could lead us to, you know, a conclusion in its own right, or it could lead to a point that we want to explore more deeply, allowing us to ask a better, more interesting question. The other reason is that it's good to produce these visualizations inside of our Markdown files. Often when we are doing this kind of exploratory analysis and trying to come to a point, our goal is to produce some kind of a memo that we can take to our colleagues or to an editor, and as we make a pitch for a story, you know, essentially asking for time or resources in order to report something out, or showing people what we have. Having visuals inside of this document can, you know, help effectively make a case that you have an interesting story. They might also serve as a jumping off point for a visualization that we might want to produce for a final story. So we might produce something in here that, you know, is pretty close to publication ready, and might take that into a different program, work with one of our graphic designers to produce something that we could drop into a story or serve as a story in its own right. And then the last point I'll say is, you know, we can actually make within our production-ready graphics that we could publish immediately if we wanted to, and I'll show you how to, you know, sort of create and output one. Okay, so let's start with a question. That's where a lot of, you know, sort of good data analysis approaches begin. So the question we're going to ask here is, how did the total number of pills sent to Baltimore City, Maryland each year between 2006 and 2012 change? Are there any trends we can identify to pursue? So I'm going to start by creating a subset of the data we loaded, which was, remember, every single county per year with a total of pills and shipments. I'm going to create a subset of this just with Baltimore City data. So creating a new object called Baltimore City pills per year, and I'm filtering out just for Maryland and just for Baltimore City, and I'm selecting two columns, the year and the dosage unit, or total pills. So when I run that, I get a very small table. This is just Baltimore City, one value total pills each year. So we can pick out some trends here, but these are big numbers and it's kind of hard to see what's going on. So this might be a case where it's nice to make a chart to try and visualize this. So this is where this ggplot library comes in. We are going to start by building a basic line chart. So the code for that is right here, and I just want to go over that. So we're going to start with this function called ggplot, and we're going to put inside of the function the name of the data frame or table we want to visualize, in this case Baltimore City per year. And then we add this plus sign, so we're basically saying like take ggplot, make a chart, and then, ggplot, so indicating that we're going to make some kind of a graphic with this data frame, and then we are going to make it a line chart. So this geomLine function basically says take the year from our Baltimore City pills table and the dosage unit, put the year on one axis, the dosage unit on the other, and draw a line chart. So let's take a look at that. All right, so what do we have here? We've got the dosage unit, total pills on this axis, up to 21 million in 1 year. Starts high, dips low. This is each year between 2010 and 2012. Okay, very basic little chart. One thing to say is if you haven't turned off scientific notation, you might get some weird numbers here. So what I would suggest at this point is take this option SciPen, and this basically says turn off scientific notation. I'm just going to leave this in the function here in case you haven't done that yet. Okay, so this time I'm going to show you how easy it is to, instead of drawing a line chart, using a slightly different ggplot function to create a bar chart. So this is almost identical to the code we had above. The only difference is this said geomLine, it drew a line chart, and this says geomBar, and it is going to draw a bar chart. Okay. So, pretty easy to visualize this trend. You have a big number of pills or dosage unit, total pills, coming into Baltimore City in 2006, even though that's missing. That's 2006. Dropped off in 07, and then it climbed steadily. Okay, so this is getting better. It's easy to pull out information, but it's still not like pretty yet. It's a little bit gray. So I'm just going to walk through a bunch of steps, and we are going to iteratively build this chart. Each time I'm going to modify the code slightly to make it a little more aesthetically pleasing or more interesting, something you'd be proud to show somebody. So the first is I'm going to change the color to like a royal blue color. And to do that, all I'm doing is adding this little bit of code, fill equals royal blue. There are other colors you could pick too, inside of my geomBar function. So this is my function above, geomBar, AES dosage unit. Down here, I'm just adding fill equals royal blue, changes the color. Okay. I think we can still improve this. So I'm going to change something very small. I'm just going to get rid of this really ugly like dosage underscore unit, and I'm going to make it say total pills, and I'm going to make this a capital Y year. And we do that by adding another plus sign at the end here, and then a new function called labs. I think it's short for labels. And on our x-axis, we want the label on the x-axis to say year, and then we want the label on the y-axis to say total pills. So when I run that, now we've got year down here on the x-axis, and we've got total pills on the y-axis. Okay, I think we can make this even a little better. So let's add a title and a subtitle and a caption. So in this function here, all I'm doing is adding a couple more arguments to the year and total pills. I'm adding in a title, I'm adding in a subtitle, and I'm adding in a caption with source information. So when I run this, I get this nice title that is declarative of the point I was trying to make, which is, in Baltimore City, opioids started high, they fell off in 2007, and they climbed pretty steadily up to 2012. Here's what the graphic is showing. Here's the year. Okay, it's pretty good. It's not finished yet, I would say. One is, it'd be nice to have every single year identified on our x-axis instead of just 2007 and 9 and 11. So I'm going to add a new function down here, and I'm just building this iteratively, right? I'm adding a plus sign. And the function here is called scale x continuous. And all I'm saying is make sure to identify these years on the axis. So when I run that, now I've got every single year. Okay, we're getting pretty good. One thing that's kind of bugging me about this is the numbers on the y-axis. It's really hard for me to determine whether that's like 200 million or 20 million or 5 million or 500,000. It would really be nice to have some commas breaking that up. So we're going to do that. We're going to add some commas to make them easier to parse. To do that, though, we're going to load a new package. It's a handy little package that works well with ggplot2 called Scales. You can see the documentation here. But it's all about like making it easy to format large numbers or add units like dollars to these graphs. Something ggplot2 just doesn't do super well by itself. So first I'm going to install it if I haven't installed it. So I'm just going to go ahead and run this. You should run that if you haven't. And then I'm going to load it. And then I'm going to just add this one little line to our function above. It just says scale y continuous, and it says labels equals comma. That only works because I've installed this library Scales. So I'm going to run that. Now we get some nice commas in there. It's easy to see this is 20 million or a little over 20 million in 06. Okay, I would say this is the final version of this graphic. Helped us identify a pretty interesting trend, which we've put in the headline here. I do want to show you one little trick, which is how to save a version of this as an image file that you could like immediately post to Twitter or something. So this function is exact same as above, right? All I've done here is I've added this one little function called ggsave, and in it I've put the name of the file, and there's an argument it takes here called plot, and what I'm saying is the thing I want to save is this baltimorepills.png is the last plot we created. So when I run this, it's going to populate it below again, but now it's also created this baltimorepills.png over here, and if you click on it, and I can shrink this down a little bit, it made this nice little image file. I could take this, I could throw it up on Twitter right now. I could email it to somebody, just pretty easy. Okay. This final version of this graphic, I want you to keep this in mind because at the end of this tutorial, I'm going to have a task for you where you're going to create a version of this graphic, but instead of doing it for Baltimore City, you're going to do it for Mingo County, West Virginia. So at the end, when you get there, this is the graphic I want you to recreate, but with Mingo instead of Baltimore. Okay, so let's move on to another question, and let's suppose we want to compare the year-over-year trend in Baltimore City to several other large Maryland counties. So to do that, I'm going to start by saving a new table, and we're going to call this Maryland pills per year, and I want to return the year-by-year total pills for the 6 Maryland counties. So remember, we have this Arcos County pills per year table that we pulled down from the Arcos API. So I'm going to create a new object called Maryland pills per year. And I'm going to add in a filter where the buyer state is Maryland. And then I'm going to also add something to this filter where I'm saying the buyer county should be one of these: Anne Arundel, Baltimore City, Baltimore, Howard, Montgomery, or Prince George's. And then lastly, I'm going to select only a handful of columns: the buyer county, the year, and the dosage unit. So when I run this, I get a new data frame up here with Maryland pills per year, and it's got 42 observations, 42 rows, one for each year for Anne Arundel between 06 and 12, one for Baltimore between 06 and 12, and so on and so on. Okay, so now we're going to build a graphic to compare them. So I'm starting by saying ggplot Maryland pills per year and a plus sign, and I'm saying make it a bar graph, fill it in with royal blue. This should look really familiar to above. I just added some customization here where I cleaned up the axis label, year and total pills. I'm putting a different title on it than we had before and a different subtitle. Otherwise, it's the same. So I'm going to populate it here. So we get this nice little chart: steady rise in opioids in 6 large Maryland counties. So what we see here is 1 bar per year in which it totals up the results from all those counties. So in 2006, in Anne Arundel, Baltimore, Howard, Montgomery, PG, and Baltimore City, there were just shy of 90 million pills. 2007, a little bit higher. 2008, a little bit higher. It might be hard to see on the video, but when you're working in your R Markdown file, you see these little like white lines here. So this is actually a form of a stacked bar graph. So each space between the lines here represents the totals for one county. And we can see that by changing the color. So I want to add another dimension to this graphic so we can start to get a sense of how things changed in each county. And to do that, all I'm going to do is add one little line to our geom bar function. So this was our geom bar function above, right, where it said fill equals royal blue. And then down here, I'm just going to add, I'm going to move this fill equals the fill property inside of the AES, or the aesthetic. And I'm going to set it equal to buyer county, meaning what I'm saying is fill the bars with a different color for each county. And now we get this nice little graphic here where you can see here's all of Prince George's County in pink, here's Montgomery in blue, here's Howard in this teal color, and so on and so on. So we can see how things changed over time. We can see the totals. One little thing that's bothering me that I would fix here, we have this legend, right, that's created over here, and it says buyer underscore county, which is just a little, I don't know, I wouldn't be proud to show that to somebody. So I just want to change that so it says county, and I'm going to do that by changing just one little thing, which is at the end of our labs function, I'm just going to add fill equals county. And what that does is it just changes the legend title here. Okay. So I would say this isn't kind of too bad. I mean, I can pull some meaning out of here. I mean, I can see that, you know, the size of the bar is relatively, like Baltimore counties is so much bigger than everybody else's, indicating a lot more pills went to that county. But it is sort of hard to see like whether the trend change was the same. It's easy to see for Prince George's County, right? Because it starts at the bottom here, so I can see it went steadily up from 06 to 11 and then fell off slightly. But everybody else starts, the bar start, or the little rectangle starts relative to where the last one ended. So it's sort of hard to see the trends. So I want to create a version of this that might allow us to do some comparison a little bit better. And we're going to create a sort of group of bar charts called small multiples. And to do that, I'm taking the same function I had as above, but now all I'm doing is adding this line here, facet wrap. So I'm going to run this and I'll explain what it's doing. So it creates one bar chart for each county and puts them next to each other. So in the facet wrap function, I'm saying n row equals 2. So sort of organize it by creating 2 rows. If I said n row equals 3, instead of a 3 by 2 grid here, I'd have a 2 by 3 grid. I think this is a little bit easier to see the trends and see how they compare. There's a lot of different meaning I take away from this. The first is, one, Baltimore just had more pills than anybody else, Baltimore County, which is interesting. Might want to explore more there. The other thing is that the trend line for Baltimore City starts high in 06, falls off, and then rises, is different than pretty much everybody else, where it started slow in 06 and rose steadily before like falling off slightly in 12. Maybe Baltimore City in that first year was sort of a harbinger of things to come, but it's definitely worth exploring more. A couple things I don't love about this: the labels are kind of a mess. 6 and 7, the years are bleeding into each other. So we can use a new function called theme that I'm just going to add at the end here. So what this is saying is take the text in the x-axis and just rotate it by 45 degrees. So same as above, the only difference is I've now just rotated the text by 45 degrees. This looks pretty good. The last thing I would say is that the legend isn't really needed here, because the labels are all Anne Arundel's here, Baltimore's here, Baltimore City's here. You have all of that right in the document. You don't really need the colors sort of coding it. So I'm going to remove that. So I'm just going to add a plus sign at the end here and a new function. So guides fill equals none. And when I run that, it just strips off the legend. So guides is the parlance for legend here. Okay, this is a pretty good graph. We're going to move on to one more graph type. And we're going to start with a different motivating question, and that is, which counties in Maryland had a disproportionately large number of opioids shipped to it relative to population size in 2012? So, you know, where we would expect counties that have more population to have more opioid shipments, but is there a way of figuring out whether or not places had even more than you would expect based on their population size? So to prepare for this, before we start graphing, I'm going to do a couple things with our original data. So the first is I'm going to create a subset of our master Arcos County pills per year, in which I'm only going to filter out Maryland counties, and I'm going to filter out the year 2012. And then I'm going to select 3 things: buyer county, year, and dosage unit, which is total pills. So when I run that, I get this new thing here. I get Maryland pills 2012, and I get one total pill number for each county for just the year 2012. Okay, so got that. Then the other side of this, right? We need to figure out whether the number it had was disproportionate to its population size. So I need to get some county population information. Luckily, the Arcos R package, the post put together, allows you to pull in easily a table with the county population data. So that's what I'm doing here, creating a new object called Maryland Population 2012. And I'm using this county population function that's part of the Arcos R API, feeding it my key. So I'm pulling in a table that has each county in the U.S. with the population for each year between 2006 and 12. Just cleaning up the names here, and then I'm filtering it. So I only get Maryland and I only get 2012. And then I'm only selecting 2 columns: buyer county and population. All right, so when I run that, this is what we get. We get each county and the population in 2012. Okay, so now we're going to put them together. So we have a single table that has county, name in Maryland, total pills in 2012, and the population in 2012. So I'm creating a new object, calling it Maryland 2012, taking the Maryland pills 2012 table. I'm interjoining it to our population table by Byer County. Then I'm selecting 3 columns: Byer County, dosage unit, which is total pills, and population. Okay, and here it is. Got the Byer County, dosage unit or total pills, and the population. Okay, so now we're going to make a scatter plot with the 2012 population on the x-axis and the total pills for 2012 on the y-axis. Each dot in this scatter plot is going to be a county, and its location on the grid will be determined by its population total and its pills total. So here's what we have. We have population on our x-axis, so each one of these dots is a county. This county has, right here where I'm clicking, has almost 1 million population. And then on the y-axis is the total number of pills. So this county here in 2012 had about 20 million pills. So again, we've created something basic. Now I want to add different functions to my main function here to make it a little bit pretty and easier to synthesize some information from. So what I did up here was I said, take the Maryland 2012 table we created, make a ggplot graph. What kind of graph? Make it a geom point or a scatter plot. And on the x-axis, put population. On the y-axis, put dosage unit. Okay, so just going to clean it up a bit. I'm going to run it, and then you can see what I did here. So I added a title. It says Maryland County population and total opioids. Added a source. Added new x and y-axis labels to make them easier to understand. Added commas to these very big numbers. So you can see that this is like 30 million pills and this is 1 million population. And then I rotated the axis label. Okay, so let's remember our question here. Which counties had higher levels of pill shipments relative to population? So in this graphic, right, we can generally see there's a trend. The bigger the county, right, the more population, the more pills it's going to have, which makes sense. But whether the specific number of pills it has is out of proportion relative to population is kind of hard to see. So in order to see this, we're going to add a trend line to the graph, or a line of best fit. Essentially uses a form of linear regression to plot a path through the data. So I'm going to run this and I'm going to show you how I modified the function to add it. So this is the same as above, right? But all I did was add this geom smooth, which essentially is a regression line. We're saying do linear regression. Don't worry too much if you don't know exactly what that means. I'll explain sort of how to interpret this in a second. So it draws this nice blue line, okay? So here's how I think you should think about this. Each dot is a county. If a dot is above this blue line, what it generally means is that it had a higher number of pills relative to its population compared to other counties. It's below the line, had a lower number of pills relative to population. So, you know, you might say sort of bigger problem in these counties, less of a problem in these counties, or fewer pills in these counties relative to population, more pills in the relative to population. Okay, so it's hard to know which is which. So let's add some labels. So I'm going to add one single line to this graph I built called geom text. Remember, we're just iteratively building these graphs. And what I'm saying is put a label around each dot with the name of the county. So geom text. Okay, so this is kind of helpful. We've got some labels here. You can see that this label all the way up at the top is Baltimore County. Really disproportionate number of pills to population size. Baltimore City is here and Anne Arundel above the line. Kind of hard to see. Prince George's and Montgomery are here below the line. Okay, I want to clean this up. It's kind of a mess. There is a way to do it using the base ggplot package, but it's kind of hard. Luckily, somebody made this really cool package called ggrepel, and it's going to make it easy for us to clean up here. So I'm going to install this package, ggrepel. If you haven't done that yet, you're going to need to install it. I'm going to load the library here. And remember, I'm just showing you how to use these things. But normally, if you know you're going to be using something, you want to load it up at the top. And our last function, I had this geom text, right? This line. This is the thing that drew these labels. Geom text, AES population on one axis, dosage unit on another, and put the buyer county here. Here I'm just replacing that with something called geom text repel, which is like a special version of geom text from the ggrepel package. And when I do that, it just kind of prettifies it a little bit. For one, it moves them away from the dot so it's easy to see. And then in this part where it's like a bunch of dots clustered together, it was smart enough to, and it's not perfect, but it was smart enough to like draw a line to the dot so that we can start to see some of these things. So like I can see that Dorchester County and Caroline County and Somerset are below, whereas Allegheny is above the line. So disproportionately high or disproportionately low. Okay, so it's still a little bit messy, I would say. It's a little hard to see some of these down here. So maybe a thing we could do would be to modify the graph so we're only showing the labels for some of the bigger counties where there's more space here. Maybe what I really care about in this case is identifying this trend with Baltimore County, and this really helps pop it out. So I'm going to modify the geom text repel function and say basically only put a label when the population is above 175,000. That's what this little line of this function does down here. So when I run this, now we're only showing the bigger counties. All of the smaller population, those down here, I've excluded. Okay, so again, what are we taking away from this? We see that Baltimore City, and Anne Arundel have a higher number of opioids relative to population. Montgomery and PG have lower numbers relative to population. So I just want to go back and adjust the title to reflect our findings. So this is the final version of this graphic. All I've done from the one we just did above was to add this new title, and I'm running this here. Okay, pretty good. So that is, we're almost at the end of the tutorial, or at least the part where I'm going to guide you through something. So you're going to have two tasks. So you're going to have two tasks that I'm going to want you to do. The first, essentially in both of these, I'm going to want you to create very similar versions of the graphics, two of the graphics we just created. But instead of using Maryland data, you're going to use some West Virginia data. So in the tutorial above, you followed the steps to create the graphic with the title "In Baltimore City, Opioids Fall in 2007, then Climb Steadily Through 2012. I'm going to scroll up right now so you can see exactly which one I'm talking about. This was the last graphic we created as part of the first sort of lesson, right? The one that says this is the final version of the graphic. And you've got the nice title, you've got the color we selected, you've got every single year identified, you've got commas, really clean. Okay, so I'm going to want you to create an identical version of this graphic. The only difference is that I want you to, instead of showing what the year-over-year trend is for Baltimore City, I want you to show me what Mingo County, West Virginia looks like. And it's going to look different than Baltimore City, so you should adjust the title to reflect the conclusion you can draw from it, what the data shows. And just a note to say, to create the Baltimore graphic, I created a subset of the Arcos County pills per year data. You're going to want to do some version of that, or almost identically that, but instead of Baltimore City, you're going to want to do Mingo County, West Virginia. Okay, that's the first one. The second one is in the tutorial above, you follow the steps to create the graphic with the title Baltimore County, Baltimore City, Anne Arundel County had higher number of opioids relative to the population in 2012. That's this graphic right here that you're looking at, the last one we just created. I'm going to want you to create this exact same graphic, but instead of showing Maryland counties, I need you to show me West Virginia counties. When you do that, I want you to adjust the title to reflect what conclusions you can draw from the graphic. Which counties in West Virginia had a higher number of opioids relative to population. You all may have slightly different answers, but things that are above the trend line are what I want you to pull out there. And again, you're going to need to follow similar steps that I took to create a subset of both the Arcos County pills per year data and to pull out a subset of the West Virginia 2012 population data. So I created two data sets. I created a slice of the Arcos County pills per year data with just Maryland data. And I created, pulled in data about county by county population for Maryland. I pulled out a table just with 2012, then I joined them together. You're gonna have to follow similar steps, so I want you to do that here. When you're all done, I want you to save the R Markdown file, knit it to HTML, upload it to GitHub, and then provide a link to GitHub in Elps. All right.